Good. So I have a function that is a natural log of another function. How do I start? Y prime. Or if you want f prime, or if you want dy over dx. They all mean the same thing. So I have natural log of a function prime. What should I start with?
The natural log of the function.
So it's a natural log of a function prime. What do I write?
1 over the inner function.
Times
The inner function prime.
Brilliant. So I have to differentiate e to negative x. I do have e to negative x, but times the inner function prime. What is the inner function prime?
-1.
-1. Plus. Now I'm in trouble. No, I'm not. But I have to understand that this, remember that this is function 1 and this is function 2. This is a product. So I have to use the product rule. The first function prime is 1, so e to negative x, plus the first function times the second function prime, which is e to negative x, as you just told me, times -1. And let me use brackets here so it's not confusing. I don't really like nested parentheses. I prefer the next level, which is a bracket. Okay, let's repeat this. Natural log of a function prime is 1 over the function times that function prime. Now, e to negative x prime is e to negative x, but this is not plain x. So if it's not plain x, I have to multiply by the derivative of that, which is -1. Now I reach the symbol plus. I realize that this is a product. I have to use the product rule. When the first function prime, which is 1, then I multiply by the second, plus the first function times the second function prime, e to negative x, times the inner function prime, which is -1. Are we okay with this so far? It's not done. Is this okay, though? Okay? So, e to negative x with minus in front is negative e to negative x, but I have a positive e to negative x. Thank you very much. So the numerator is negative x e to negative x, and the denominator is e to negative x plus x e to negative x. I realized one thing, that there is a common factor in the denominator. Can anyone dictate the common factor in the denominator so I can pull it out?
E to negative x.
E to negative x. Can anyone tell us what to write in parentheses?
1 plus x.
Indeed, 1 plus x. Goodbye. Thank you very much. And I have negative x. I don't like this order. X plus 1. Very good pick. It was a little challenging. We had the product rule, we had the chain rule, we had the natural log. That was good. Okay, so let's see if we want to look at another before we discuss log in any other base but e. Okay, I will choose one. I want to choose, what do I want to choose? I am going to choose 12. I'm choosing 12, and then we'll look at anything else. So 12, we have p of t, natural log of the square root of t squared plus 1. Can anyone help us with this, with p prime of t? How do we start?
Is that 1 over natural log? Oh wait, square root of t squared plus 1.
1 over 2 bracket 2t.
Awesome. Okay, so here we see 1, 2, 3. So first, I differentiate natural log. When I differentiate natural log, I have 1 over this times this prime. Now I uncover, oh, I see the square root. Okay, I just refreshed my memory on the square root. The square root of a function prime is 1 over 2, the square root of function times the function prime. So it's 1 over 2 the square root times the inner function prime. And this is done. It's not simplified, but the differentiation process has ended. Of course, these are factors. Of course, I like this. When I multiply these two, what do I get?
T squared plus 1.
And this is it. And that's final. Indeed. Okay, so now let's look at what happens. So when I have, if you remember, when we have e to the x prime, we get e to the x. Can anyone refresh our memory? If we have any number, not e prime, what do I get?
A to the x times x times natural log of a.
Very good. Awesome. Brilliant. Thank you. Similar situation we have with natural log. So these are somewhat related, right? So this prime is 1 over x. But now, if I have log base a of x prime, what will happen here is this will be 1 over x times, in the denominator, natural log a. Okay, so now we can choose anything you'd like with a base other than e. So this is weird enough, I think. So let's look at 26. I'm copying it. Y equals log base 2 of x times log base 5 of x. Fine. So where does this come from? Let me explain, because I just showed you the formula, but let me explain. We have to change the base. So before I come here, allow me to explain that situation. So if we have log base a of x, this is the same with natural log x over natural log a. This is the change of base formula. So basically you can say, oh, so you're not really differentiating that. True, I'm not. I'm differentiating this instead of this. So in our minds, although we are not applying this procedure, but that's what we are doing. We refuse to differentiate this. We change the base into this, and that's how we get 1 over x times natural log a. Because the derivative of this is 1 over x, and this is a number. So this is kind of a little lie if you want. We're not really differentiating this. We're differentiating this by the change of base formula. And that's how we get the natural log A in the denominator. Oh, where am I here? Okay. So when we differentiate this, maybe I shouldn't write it here because I'm going to run out of room in a blink, in a jiffy. I always run out of room. So let me copy it. So now here's a challenge. Why? First of all, I have a log base 2. So remember, we are not really differentiating that. I have to have log base 2 in the denominator, natural log of 2 in the denominator. But then this is a function that is a product. I have to worry about it as being function 1 times function 2. So first of all, y prime. I have the derivative of this, so log base 2 of this is 1 over this, x log base 5 of x, times, remember, natural log 2, and now times this inner function, prime. I have to get it ready because this is a product. And the product, when I differentiate a product, is always a sum of 2 terms. First function prime, fine, it's 1. So then log base 5 of x plus the first function, but now times this. And remember, we are not really differentiating this. We are differentiating natural log x over natural log 5. So when I differentiate natural log x, it's easy. I have 1 over x, but I have to have natural log 5 in the denominator. The only thing I need to do is this. And leave it alone. There is nothing else we should do here. So y prime equals 1 over x log base 5 of x times natural log 2, and then times log base 5 of x plus 1 over natural log 5. And this is it. Don't try to do anything else here. So let's think for a moment and see if you have any questions here. Are these steps understood? So maybe I should have given here the formula, the general formula also. Natural log base a of the function prime equals 1 over the function times natural log of this base, of course, times the inner function prime. What's different here? Well, if I have natural log of a function, then I have 1 over the function times the function prime. How come that I don't write natural log e? I don't, because natural log e is 1. That's why I don't write it. But it should be there. But natural log e is 1. That's why we don't need it. I don't want to confuse you, so I'm deleting that. Any questions? Any questions here? Okay. Now the next topic is extremely important. Very, very, very important. So when we differentiate a function to power n, can anyone refresh our memory on this rule? Any function to a power. How do we differentiate that?
Is it going to be m as the power of m minus 1?
Times f5.
Very good. Always, you should always say that in your head. Perfect. Now, this n must be a number for this property or rule to be applied. Okay. Now, what about this situation? A function raised to another function prime. This is not a number. G is a function. So a function raised to a function. Here's an example. Let's say cosine x raised to power natural log x squared. Cosine x is function f. Natural log of x squared is function g. How do I differentiate something like this? One thing is certain. Do not use the rule from above. This is the first very important answer. Do not use the rule from above. Not. Okay, so there is a long process here. It's called logarithmic differentiation. I always run out of room. You know that already. No secret there. Okay, logarithmic differentiation. And you can say, what are you talking about? Okay, here's our function. I just made it up. This is function y. Cosine raised to the power that is a function. I can never think of this. It will be a waste of time. It's not applicable. So I will apply log to both sides. Step number 1, apply log to, of course, natural log, not log. I want only natural log. I'm going to erase that to both sides. So natural log here and natural log on this side. Okay, fine. I applied natural log to both sides. Now what? Can anyone look at this new equation and say, oh, I know you're going to have to do this first? And I'll probably do it.